Hello to everyone. In this session, we have to discuss about problems on Cauchy's root test. The first problem is test the convergence of the series 1 plus x by 2 plus x square by 3 square plus x cube by 4 cube plus dot dot dot. Solution of this problem. Here the x starts from second term, so that's why we have to neglect the first term. First we have to find nth term of the series. So an is equal to, so the nth term of the series is at numerator x raised to 1, x raised to 2, x raised to 3, so we get x raised to n. At denominator we have 2, 3, 4, so nth term is n plus 1. So power 2 raised to 1, 3 raised to 2, 4 raised to 3. So the power is its nth term is n. Then consider an whole raised to 1 by n. So that is equal to x raised to n divided by n plus 1 whole raised to n whole raised to 1 by n. So for numerator and denominator we have common power n, so that's why n and get cancelled. We get x by n plus 1. Next we have to apply limit on both sides as n tends to infinity. So we get limit of an as n tends to infinity whole raised to 1 by n is equal to limit of x by n plus 1 as n tends to infinity. After applying the limit we get x by infinity. So x by infinity is equal to 0, that is less than 1. Therefore by Cauchy's root test the given series is convergent. Second question, test the nature of the series summation n is equal to 1 to infinity n plus 1 by n whole raised to n square divided by 3 raised to n. Solution. Here the nth term is un is equal to n plus 1 by n whole raised to n square divided by 3 raised to n. Next consider un raised to 1 by n. So apply the limit on both sides as n tends to infinity. So we get limit of un raised to 1 by n as n tends to infinity is equal to limit of n plus 1 by n whole raised to n square divided by 3 raised to n whole raised to 1 by n as n tends to infinity. So after simplification we have limit of n plus 1 by n whole raised to n divided by 3 as n tends to infinity. So at numerator we take an n side, there n get cancelled, so we get limit of 1 plus 1 by n whole raised to n divided by 3 as n tends to infinity. So here limit of 1 plus 1 by n whole raised to n as n tends to infinity is e divided by 3, so we get e by 3, so that is less than 1. Therefore by Cauchy root test given series is convergent. Next problem, test the nature of the series 1 cube by 3 plus 2 cube by 3 square plus 3 cube by 3 cube plus 4 cube by 4 raised to 4 plus dot dot. Solution. Here the nth term of the series is an is equal to, so 1 cube, 2 cube, 3 cube up to 4 cube means nth term is n cube, and at denominator we have 3 raised to 1, 3 raised to 2, 3 raised to 3, so nth term is 3 raised to n. Next consider an raised to 1 by n, that is equal to n cube by 3 raised to n whole raised to 1 by n. Next we have to apply limit on both sides as n tends to infinity, so that is equal to limit of n cube by 3 raised to n whole raised to 1 by n as n tends to infinity. So here we this is equal to 1 by 3 into limit of n raised to 1 by 3 whole raised to 3. So we know that limit of n raised to 1 by 3 as n tends to infinity is 1. So 1 cube is 1. So we get 1 by 3, that is less than 1. Therefore, by Cauchy's root test, the given series is convergent. Next problem. Test the convergence of the series summation n plus 1 by n whole raised to 2n square. So here the nth term of the series is an is equal to n plus 1 by n whole raised to 2n square. So consider an raised to 1 by n. So we get n plus 1 by n whole raised to 2n. There n get cancelled. So again n plus 1 by n can be written as 1 plus 1 by n whole raised to n whole raised to 2. Then we have to apply limit on both sides as n tends to infinity. So here limit of 1 plus 1 by n whole raised to n as n tends to infinity is e. So we get e square, that is greater than 1. Therefore, by Cauchy's root test, the given series is divergent. Next problem. Test the convergence of the series summation n by n plus 1 whole raised to n square. Solution. The nth term of the series is an is equal to n by n plus 1 whole raised to n square. So we have to consider an raised to 1 by n, that is equal to, so we get n by n plus 1 whole raised to n. There n get cancelled. Then we have to apply limit on both sides as n tends to infinity. So this can be written as limit of n divided 1 by 1 plus 1 by n whole raised to n. So limit of 1 plus 1 by n whole raised to n is e. So therefore we get 1 by e. So that is less than 1. Therefore, by Cauchy's root test, the given series is convergent. Next problem. Test the convergence of the series summation 1 plus 1 by n whole raised to minus n square. Solution. The nth term of this series is an is equal to 1 plus 1 by n whole raised to minus n square. So next, consider an raised to 1 by n, that is equal to 1 plus 1 by n whole raised to minus n. So n get cancelled. Then apply limit on both sides as n tends to infinity. We get 1 plus 1 by n whole raised to n whole raised to minus 1. So limit of 1 plus 1 by n whole raised to n as n tends to infinity is e. So e raised to minus 1. So that can be written as 1 by e, that is less than 1. Therefore, by Cauchy's root test, the given series is convergent. Next problem. Test the convergence of the series summation n raised to n divided by n factorial. Solution. Here the nth term of the series is an is equal to n raised to n by n factorial. So next, consider an raised to 1 by n is equal to n by n factorial raised to 1 by n. So apply the limit on both sides as n tends to infinity. So we get limit of n by n factorial raised to 1 by n as n tends to infinity. Here limit of n by n factorial whole raised to 1 by n as n tends to infinity is e. So e is greater than 1. Therefore, by Cauchy's root test, the given series is divergent. So in this session, we have discussed about problems on Cauchy's root test. So these are the reference books to use this session. So thank you one and all.